Example 4.1, use source transformations to calculate the current to the 3 ohm resistor. To use source transformations, no transformation can be done to the series branch of the 10 volt and 3 ohm resistor. So let's start with the first transformation. So when you look at the circuit, here's what it looks like. So when I'm looking at this thing, what I want to do here is that I'm going to focus on this branch right here. So my first transformation is then I'm going to convert my Rn, which is the 8 ohm, and my In, which is 2 amps, and then I'm going to convert that into I'm going to put that into a series and a 16 volt and 8 ohm. So I'm going to do this. I'm going to have my 10 volt, and then you can see here is that I have my 6 ohm. So here's my 6 ohm, and then here's my 3 ohm. And now what I just did here is that I did a conversion. So if I do that conversion, that means I converted this guy to the same Norton and Thevenin resistance, and then I multiply the resistance times the current, and I'm going to get a voltage source that reads like that. So this will be my 8 ohm, and this will be my 16 volt. And you can see here is that I have not touched that 4 ohm resistor. So now what I'm going to do here is that I'm going to do another conversion. So my second conversion, as you can see here, is that I have a 4 and an 8 in series with a voltage source. So what I'm going to do now is that I'm going to convert my Thevenin resistance, which is 8 plus 4, which is of course 12 ohms. And then I have my Thevenin voltage, which is 16 volts. And so what I'm going to do here is that I'm going to copy this guy. I'm going to bring it down here. And now what I'm going to convert here is that I'm going to take this guy and I'm going to focus on this branch right here and this branch right there. And now I'm going to do my source transformation. So if I do my source transformation, the resistance is still the 12 ohm, but now it becomes a Norton resistance, which is parallel. So I have my 10 volt, I have my 3 ohm, and I have my 6 ohm. Right, so here's my 3 ohm, here's my 6 ohm. So what I've converted here is that now I create a Norton resistance, which is 12 ohm. And now I have a current source, which is going to be 16 divided by 12, which gives me 4/3 amp. So now I'm going to copy this circuit right here. And I'm going to look at my third conversion. And what I'm going to do here is that I'm going to convert my Rn circuit, which in this case is going to be 6 parallel to 12, which gives me a 4 ohm, and my Norton current here, which is 4/3 amps. I'm now going to convert that into a Thevenin circuit. So if I look at where I'm doing this, you can see here is that I got a branch, two parallel branches. These parallel branches here. So if I convert that, I get what? I have a 10 volt. I have my 3 ohm. And so now I'm going to create a 4 ohm, and I'm going to create a voltage source that's 16/3 volts, because I'm just multiplying 4 times 4/4 here. And again, here's my 3 ohm resistor. So I'm seeing that my current of the 3 ohm resistor is still in this direction. So all I got to do now is that I'm now gonna, because this is a series circuit, I'm gonna use Ohm's law to calculate this current. So if I do that, I see that this is going to be I 3 ohm. This is going to be 10 plus 16/3 divided into 3 plus 4. And my final result is 2.19 amps for the current of the 3 ohm.